Welcome to a small demo of holdec version 1.3. Holdec is a decompiler for binary programs. It currently supports the 32-bit Intel architecture and the Motorola 68000 chip. There is a public repository of decompiler subjects on GitHub. From this repository, a small command line program will be used for this demo. I will start a decompiler now. And of course, the first thing is to open the program. There are multiple views which allow you to examine the program and decompile parts of it. In this demo, I will only show the most important views. The first step after loading a program is to ensure that the code and data is separated and that the assembler blocks can be grouped to functions. The global assembler view helps here. It will show a marking on the right side if instructions cannot be decoded, if code runs into data or some other problem arises. The colored lines on the left side help to determine function boundaries in case a block is shared between two functions. In this well-formed demo program, no real action is required. Let's take a look at the call reference view, which shows the calls inside the program in a table. It looks like there is a proper main function. Main calls hexdump, and hexdump calls various file-related functions, but also dumpline. Dumpline, on the other side, calls various string functions and printer. So together with their names, one has a rough idea what these three functions do. So finally, let's take a look on the decompile view. We start with the function dumpline by selecting it and run the decompilation. The main part of the decompile view shows three code displays. The first shows the assembler blocks. This is a subset of the assembler blocks of the complete program. The second part shows the decompiler output as blocks. Note that these blocks do not have to correspond to the assembler blocks. The third and final code display shows the decompiled code in a structured way with if-else and loops. We see that the decompiler automatically detected three parameters based on the stack access pattern inside dumpline. The type D4 means a 4-byte integer of unknown signedness. To get some idea what the parameters may mean, we search for the occurrences of arg0, arg1 and arg2. There is no easy guess for the first two, but arg2 is used as an upper loop bound, so we may assume that it is some count. We change the name, and after another decompile run, the code views are updated. We also notice that some stack offset, here 20, is used as a counting variable. Looking at function hexdump, we see that holdec displays the control flow in a nice way. It is easy to guess that arg0 is a file name. We change it and rerun. In the decompiled code of the main function, different to the other two functions, no stack accesses occur, but the assembler contains such accesses. The reason is that for the main function, the decompiler was able to infer that no stack offset is aliased, and thus could create proper variables. The code of all decompiled function is written to a local file. You may want to compare this to the original source code. Thank you for watching this short demo, and have a nice day.